The blood supply of the testes is distributed outside of the seminiferous tubules. This is where the blood vessels branch through and provide nutrients and oxygen. The situation in the seminiferous tubule is similar to that that we saw in the skin. Recall that the epidermis, epithelial tissue, is avascular. There's no direct blood supply there. Compared to the dermis, connective tissue has a blood supply, and the blood vessels go right up into the dermal papillae, and what will happen is nutrients and oxygen will diffuse from the dermis into the cells of the epidermis. To relate this to the seminiferous tubule, what we're looking at with number one is the basement membrane. That's the outer periphery of the tubule. Okay, this is the hollow lumen of a seminiferous tubule. These tall pink cells are sustentacular cells. And so we said that the blood supply is distributed throughout the outside of the seminiferous tubules, doesn't penetrate into the seminiferous tubules. Therefore, the spermatogenic cells that are present on the outer periphery, the spermatogonia, those spermatogonia have not yet started to undergo meiosis. And so the spermatogonia are the only spermatogenic cells that have, more direct contact with the blood supply. The sustentacular cells contact neighboring cells by forming a tight junction, which they're showing us here. So one sustentacular cell is going to physically fuse to the neighboring sustentacular cell, and this is what's physically known as the blood-testis barrier. Once a spermatogonium starts to undergo meiosis, even before it divides once, what will happen is that cell is going to get pushed past the blood-testis barrier onto the other side of this barrier, and that's known as a primary spermatocyte. Then the cell is known as a primary spermatocyte. And it's going to continue on with meiosis. So as long as the cells aren't undergoing meiosis and they're on reserve on the outer periphery, the spermatogonia, they're in that outer compartment that's known as the basal compartment. And so what we're saying is that this blood-testis barrier is going to divide the seminiferous tubule into two parts. The basal compartment that contains the spermatogonia that have not started undergoing meiosis, and once they start to undergo meiosis, they're going to push past the blood-testis barrier into what's known as the adluminal compartment. And the adluminal compartment, good name, is the one that's right next to the lumen. And this contains cells that are undergoing meiosis that only receive nutrients by diffusion. So again, sustentacular cells, labeled 7 here, the tall cells that do not turn into sperm cells, attach to each other using a tight junction. And so that tight junction forms the blood-testis barrier. And what it does effectively is it divides the seminiferous tubule into two compartments. There's the basal compartment that contains spermatogonia. Those spermatogonia are not undergoing meiosis. Once a spermatogonium starts to undergo meiosis, even before it divides one time, it's pushed past the blood-testis barrier into the adluminal compartment where it undergoes meiosis and turns into a sperm cell. Here's another view of the same thing. They're zeroing in onto seminiferous tubules. We can see the blood supply is distributed outside of the seminiferous tubules, and what they did in this picture is they highlighted where the sustentacular cells are fusing together with tight junctions, and we can see it's forming the basal compartment. That's where the spermatogonia are located, and then the adluminal compartment, the compartment next to the lumen, where cells are undergoing meiosis. So the advantage to the blood-testis barrier is that spermatogonia, males are born with spermatogonia. Those cells are normal body cells. They're not different in any way compared to a sperm cell, very different. They would be recognized as foreign by the male's body, and so we don't want to risk having those cells come into direct contact with white blood cells. And so what we do is we push those cells past the blood-testis barrier where they'll only get their nutrition by diffusion, and they won't be attacked as foreign.